The topic we are going to discuss about is chemistry of hydrocarbons. And the subtopics are atomic orbital treatment of benzene and resonant structures. Let's learn in detail about atomic orbital treatment of benzene. Each carbon in benzene is sp2 hybridized. The three sp2 hybridized orbitals on each carbon atom are utilized to form three sigma bonds, two with adjacent carbon atoms and one with hydrogen. So each carbon atom in benzene is sp2 hybridized. That's why it has three hybrid orbitals. उन तीन hybrid orbitals में से दो hybrid orbitals adjacent carbons के साथ sigma bond बनाते हैं, जबकि जो एक hybrid orbital है वो हाइड्रोजन के साथ sigma bond बना रहा होता है. क्योंकि कार्बन एटम जो है वो sp2 हाइब्रिडाइज है, जिसकी वजह से उसके पास एक 2pz ऑर्बिटल प्रेजेंट होता है. The unhybridized 2pz orbitals partially overlap to form a continuous sheet of electronic cloud enveloping above and below. So these unhybridized 2pz orbitals are perpendicular to the sp2 hybrid orbitals और ये आपस में above and below the plane pi इलेक्ट्रॉनिक क्लाउड बनाते हैं जो कि सिग्मा बॉन्ड्स को प्लेन के ऊपर और नीचे दोनों साइड से कवर कर लेता है. सो इट फॉर्म्स अ एनवेलप जिसके अंदर सिग्मा बॉन्ड्स प्रेजेंट होती है. Next is the resonance method. The possibility of different pairing schemes of valence electrons of atoms is called resonance. Different structures thus arranged are called resonance structures, denoted by double-headed arrow. Here we have the structures. 2 are proposed by KEMU while 3 are proposed by Dewar structures. So ये वो structures हैं जो different pairing scheme of valence electrons की वजह से form हो. First 2 were proposed by KEMU जो हमने देखे और जो later 3 थे they were proposed by Dewar. The stability of molecule increases with increase in the number of its resonance structures. So जितने ज़्यादा किसी भी molecule के resonance structures होंगे उतनी ज़्यादा उसकी स्टेबिलिटी होगी. द मॉलिक्यूल ऑफ बेंजीन इज क्वाइट स्टेबल और जितनी ज्यादा स्टेबिलिटी होगी उतना कम वो रिएक्टिव होगा. So we learned about two structures that were of KEMU and second were of Dewar. So जो Dewar के structures हैं उनका contribution towards the benzene final structure is minor क्योंकि Dewar ने जो structures propose किए उनमें जो bond है that is between 1 and 4, 2 and 5 और 6 and 3, जबकि ये highly unstable bonds हैं. They are not feasibly possible. That's why इनका जो contribution है वो बहुत minor है. Next we have the resonating or conjugate bonds. The three alternating single and double bonds in KEMU structure are called conjugate or resonating bonds. Can be represented by a circle. So ये जो alternating single or double bonds हैं, ये जो तीन double bonds आप देख सकते हैं KEMU के structure में, these are the resonating or conjugate bonds. और अगर आपने bonds नहीं बनानी तो you can represent it as a circle. Since benzene is a resonance hybrid, therefore all the CC bond lengths are different from the other hydrocarbons. Like in alkanes, so CC bond length that is 1.54 angstrom. In alkanes, it is 1.34 angstrom. In alkynes, it is 1.20 angstrom. जबकि benzene में it is 1.397 angstrom. Let's discuss a question. The resonance energy of benzene is about 110 kilojoule per mole, 236 kilojoule per mole, 120 kilojoule per mole, or 271 kilojoule per mole. And the correct option is 120 kilojoule per mole. So this was all about the atomic orbital treatment of benzene. I hope you have understood it well, and thank you so much.